We continue with our discussions on the water reticulation system. In these videos, we're going to demonstrate some examples of water reticulation plans to help you with better understanding regarding the informations to be provided in the water reticulation plan. First, we have the water reticulation mains plan. It demonstrates the layout of the water reticulation system, the existing layout, and the proposed layout. You will need to show the existing layout, indicate clearly where you are going to tie in your water reticulation system to the existing. This plan is on basis of the subdivision plan approved by the state planning authorities. You may also refer to the engineering plan, giving the information of the roads and drains, particularly the culvert, as this later will influence how you're going to design your water reticulation systems. Provide legends to demonstrate the symbols that can be found in the water reticulation plan. This shall include the fire hydrant, the water mains, the sub-mains, sluice valve, and etc. If your water main is crossing the culvert, there shall be a change of elevations in terms of the water mains, and then you need to provide air valve in order to release the air bubble from the water reticulation system. This briefly explains the water reticulation's mains plan. Other than that, you will need to provide the details of the components in the water reticulation system, such as the truss block for bend, pipe connections, the end hydrant and end anchorage, pillar hydrant, air valve, pipe crossing for RC culvert, communications pipe, flow meters, and others. We shall only briefly go through the relevant details for you to have an idea how these components looks like. Taking the end hydrant and end anchorage as an example, normally you find this at the end of your water reticulation system that is used to remove the sediments in the piping system also. There are several types of details here. They look similar in terms of the design, but there are some distinct differences due to the type of materials as well as the type of the joint. You will see differences here. To make it simple, you know that the water reticulation mains can be made of two main categories: the flange joint and the spigot joint. The mains can be made of ductile iron pipes or the HDPE pipe. There are also stub ends with flange. For example, this stub end and flange here. This is the stub end and this is the flange to be connected with the flange of the T-joint here. If you see the detailing here, this is HDPE pipe and this is DI T-joint. DI T-joint looks something like this. This shows how the joint is being connected. The details of the pipes are also given. You know that this is 150 mm diameter. The details of the T-joint also given. It is 150 mm diameters times 100 mm diameter. By looking at the aspect ratio here, you know that these two ends is 150 and this end it will be 100 mm diameter. You have 100 mm diameter sluice valve, which is later to be connected with the pillar hydrant of 100 mm Now this whole thing here is to be connected with the concrete block in order to ensure the stability of the water reticulation mains. The diagram here shows the plan view of the concrete block. You will have an RC square house of 150 mm size. The dimensions are given for the concrete block. This is the reinforcement bar, BMC AA8. You see the cut section here, II, which looks something like this. This is the 150 RC power, and then this is the end of the pipe, which is later to be connected with a T joint and sluice valve plus the fire hydrant. The dimensions is given here and the reinforcement. This design is different from this design in terms of the types of the connections. This is the flank connections. This is the spigot connections. The other detailings are similar. This brings us an idea. You really need to know what you are doing while producing the technical drawing for your water reticulation system. Especially come to the type of the joint. Let's say you are proposing the pipes with the spigot joint. You have to consider how you're going to connect with the other fittings if they are made of flank joint. If you provide fitting in the spigot joint also, that shouldn't be a problem. But if you are proposing the otherwise, you have to come up with a mechanism to join them. This is one of the lesson points that you can gain through the drawing here. Next, let us look at another example in terms of the detailing for the water reticulation system. This figure shows the typical pipe connections joint, which looks similar like this. It shows a junctions of the water reticulation plan. You have the big water mains, which is later to be joined with a sub-main. You normally see this type of connections at the junction here, where you have the big water mains, later joined with a sub-main, connecting and doing looping for the buildings at the opposite side. As you've seen from the water reticulation plan, there will be two joints here, and normally there will be a sluice valve at the joint. The big water mains, normally the diameter is 150, and the diameter is about 63. This leads to changing in terms of the size of the pipe from the mains. You will need fittings to create an additional branch of the pipes, something like this. Now the main difference between this and this, it will be the type of the joint. This is for the flank joint, and this is for the spigot joint. The rest, it will be similar. Compared with this one is slightly special. If you see the detailings here, this pipe is most likely an existing DI pipe. That means initially you have one existing pipe passing through here. Now you would like to tie in the pipe with this existing DI pipe in order to connect with your 63 mm diameter pipe. Therefore, you will need to cut the sections from the existing pipe, connect the fittings, so that you create an additional water outlet, allowing it to flow into the 63 mm pipe. The details also tells you the type of the connections. In this case, which is the electrofusions coupler, which is connected by using this method. This method is normally used for the HDPE pipe. As for this part, it will be the stud with flange, which is this. Imagine the stud end with flange, and the other end here is to be connected using the electrofusion coupler with another HDPE pipe. This is how the details here looks like. You will need a taper fitting here, because the T-joint here end up to be 100 mm diameter. This is connected with the Swiss valve, also 100 mm diameter. The 100 mm diameter Swiss valve cannot be directly connected to the 63 mm diameter pipe. That's why you need a tapered fitting here, changing the diameter from 100 mm to 50 mm, so that it can be perfectly fit with the 63 mm pipe diameter. Same design goes here. And then you will see concrete blocks to keep the joint in static conditions. This is the plan view. 150 RC pounds. The dimensions are given here, and the reinforcement BMC A8. You may refer to the details of DD section here. Imagine you cut a section here, view from the side, which should look something like this. This is the water main 150 passing through the concrete block, and then you have a T-joint here creating an additional outlet of 100 mm diameter that is later to be connected with a Swiss valve and then a tapered fitting before entering with the joint for the 63 mm diameter HDPE pipe. This is the reinforcement bar, and the dimensions are given here.